Okay, hi, this is Will, and this is the third installment of the Wonderware HMI. And what I had done is before we had these timers timing in a really short interval. And what we wanted to do is, I wanted to change these to 5 second intervals so we could kind of watch what's happening. And I wanted to show you one important thing about how some of these tags are identified in Wonderware. So we've got the counters or two timers cycling between each other. So it's 5 seconds on here and 5 seconds on here, total of 10 seconds. And they'll cycle 6 times, and then we'll get this end of cycle. I changed that name from like counter complete or something. And now T1 is timing when T1 is enabled. So I just copied this down here to say when T1 is timing. T2 timing is the same thing except when T1 is also high. So we've got two new signals for T1 and T2 timing, and then we have the end of cycle. So I'm going to go in here, and before we had three things that visualize the start process. We had this pilot light, we had this message, and then we had this, which was kind of simulating an LED. So I'm just going to move him over here, and I'm going to, instead of start process, I'm going to say he's now T1 timing, and that doesn't exist, and we'll give it a Boolean. Okay, and we'll leave him green. Now I'm going to copy him, so I'm holding down the control key, and I'm just going to change that to T2 timing, and I'm going to make him, we'll create bool, and we're okay. And now I'm going to make him this light blue color, and that's okay. Now I'm going to copy him down. I'm going to push him a little further down here, and we're going to make this end of cycle. Okay, so he doesn't exist either, so that's a bool, and we're okay. Now I'm also going to go in and temporarily put some text in here for first timer, and I'll put in second timer. And I'll copy him down here and just make that end cycle. Now we still we're all set up here, and we're all set with the PLC program, but we have to put these guys into our main driver sheet. So I'm going to double click here and say T1 timing, T2 timing, and end of cycle. Now what I'm going to do is I'm just going to I'm going to try to copy these and just paste them down here. Now what we have for this, I put them on the next available bits here. So C6 and C7, but this one is CT1. So first let's look at the C bits. So we'll go into the address picker, and we'll go into our C bits, and C6 put in for the display the Modbus. So C6 is going to be 90, and C7 or T2 timing is 91. So we'll go into here and we'll make this 90, make this one 91. Now here's the one that I wanted to show you, because what we're using for this is CT1. This is an output from here. And before we were saying that the coils were, generally speaking, 0x as the prefix. But let's take a look at this CT1. So you have to go in the address picker again, and we have inputs, outputs, we have the relays, the internal timers, and then counters. So if we go into CT1 and then we go into displaying the Modbus address, Okay, that is 149,153. Now, this is an output, and we said that we use 0x when we want to read and write to that address. Now, this is an output of this function, of this action. So we cannot write to that. We can only read that function. And the same for the outputs for like this timer in here. We cannot read to that. And I'm not sure, like, if we read to that, that the counter reads right over it once again, but we can't do that. So instead of 0x, that really is going to have to be 1x, and then the number is going to be 49,153. So if we go in here and we change this to 1x and 49,153, and I think that's what we need. So let's connect up and let's load this program in. And I think it's 1x 49,153. There's always a chance it's 1x and then 149,153. We'll find out. So we'll write the program into the PLC. And stop it and start it. And now we'll go in here. We'll put this in run mode. And we're just going to, well, okay, we're stopped. We're at end of cycle right now. So that is correct. Now when we hit reset, everything's going to go out. And now when we start our count, this goes on and it's going to cycle back and forth. And where we're going to go with this, well, one thing I want to show also with this end of cycle is we're going to use the visibility display that you can, we put on an animation for colors, but we can also put up messages and we can make them visible depending on some of these tags. And one of the things is sometimes you don't want to clutter the screen too much, but you only want information to appear when it's usable or when it's worthwhile to have on the screen. So when we get to the end of the cycle, we need to hit reset, but it's not obvious if just this light comes on. So what we're going to use is we're going to use this lamp to put up a little message that'll say, you've reached end of cycle, you need to hit the reset button to continue. And the visibility is something I use all the time. And hopefully we're getting close to, okay, so this is end of cycle. So let's just verify that with our PLC program. So yeah, we have reached end of cycle. So the important thing is, for that one, we have to have that as 1x, and then it's 49,153. And if you look in there, and if you look in the address picker, it does have the 1 in front of it, but that's part of our prefix. So that 1 is going to appear. Also, when we're going to look at some of the other registers in here, this will be a 4x for some of these registers. And if we look at some of the counters, the actual count value, which is an integer, if we look at that, it also is going to be 4x 49,153. So you can kind of take a look at that address and what that leading character is, and know whether it's you're going to have to trial and error, but you can kind of see whether it is going to actually be a 0x prefix, a 1x prefix, or a 4x prefix. And if you understand that, you can save a little bit of time. So we have this end of cycle that only becomes true when we have reached the end of the cycle. So we're going to take the same message that we had before, the smart message, and we're going to put one down here, and we'll click on it. Now The tag we're going to use is going to be the end of the cycle tag. Okay, so it'll be the end of cycle tag. The message we're going to have is when it reaches 1, let's see, end of cycle, hit reset to continue. And let's see, we can just have text in that, and well, let's see. I'm not sure I'm going to like this color format, but we'll go with it for the time being. So, okay, so that's a little too big. Let's shrink it down a little bit and put it over here, and maybe just bounce up the font size some. So let's see what that looks like. Okay, so anyway, we're going to go through this one more time, and what we have to do is if we go into these graphics, we can give this visibility too. So we gave it a message here, but now we're going to make visibility. So if we highlight this and we say what's the visibility tag, we're going to still make it the end of cycle. So it'll be the end of cycle tag. So unless this goes on, this message isn't going to appear. So if we run this, and oh well, here it blinks too, so even better. So now let's stop it for a second, we'll reset it, and now when we start, we'll go through our systems on, and it'll blink back and forth, and then when we get into cycle, this will appear. And I was just looking when it's blinking at us, one of the things, if you're, when you're doing this just to practice, and get used to it, you can do things with have really obnoxious blinking little messages, but that's not something you'd want in a regular HMI system. You have to think about an operator needs to be working at this for 8 hours a day, so it needs to be clean and not cluttered, but also not something where if that was blinking at you 10 times a day, you'd want to know who came up with that really obnoxious screen for why it was always blinking at you all day. But here you can say, it'll give you a message that says, hey, you've reached the end of the cycle. What you need to do to continue is you need to hit this button. And that was kind of the only thing that we wanted to show with that. But a lot of times you can use visibility to display something. Yeah, and we always use it for, if we have a message for a fault. And, again, you'll have to, use your own discretion for how much you want to show it. But that you can either have it where, and you can have another message that you could have system normal, and then if there's a fault, it would light up that says system fault. So it would be system on, system normal, and then system off, and it could say system fault on here. So you'd have some idea of what was going on, but the visibility is a good thing if you only want to show messages when they're applicable to what you're doing. And that's what we just want to show there. The visibility is a really useful function, I think. So that's the end of this one. And the next time we'll do a little more, and we'll actually put in some visibility on some showing you what these timers are timing out. So we're going to add some actual readout numbers so you can take a look at what the values are as they're counting up. So that's a useful function too, is to look at actual values. So we'll see you next time.